Okay, so in this pre-quiz video, chapter 6, we're going to work on exponentials and logarithms. So I'm rewriting this logarithm exponential into logarithm form, so log base 6 of 1296 equals 4. This one I'm solving, right? So I really want to know 81 raised to what? So you just put equals x if you want to. 81 raised to x equals 3. You need to write them the same base, so 81 is 3 raised to the 4th. So that's 3 raised to x. This exponent on the 3 is 1. Now when I raise powers to powers, I can multiply that. And now that the bases are the same, I can set the exponents equal to each other and solve for x. So divide by 4, I get 1/4. Okay, looking for this value, what that value of k, I just find my asymptote, which is where the graph is not touching, but really you'll see it kind of always will be on these graphs. Your graph will be touching the asymptote, so what line is the graph kind of running along? So that'd be x equals 0. And so that's my asymptote. Then I just go 1 over to the right, and I see where's my graph cross that line. 1 over to the right there at y equals -3. So my k is -3. Okay, on this one, I have two graphs. I'm going to graph this one. Easiest way to graph is take your h plus 1. So that is compared in, and we'll really do it on this next one, is y equals a log b of x minus h plus k. Now, I take what's inside the parentheses and I set it equal to 0, and that's what my h is, where my asymptote will be. So if I set that equal to 0, I get x equals -2. So that's really my h, -2. So at -2, I have a vertical asymptote going through. And then here I just take my h plus 1, so that'd be -1. And then whatever I get out is going to be my k value. And my k value here is nothing. Nothing's being added to at the end. So it's going to be 0. So I'm at -1, 0. So at -1 at 0. So that would be my first point. So -1, 0 would be here. Oops. Okay, and then the second point you can always find is just what makes this the same as the base. So if I plug in 2, I will get 2 plus 2 is 4. Log of base 4 is 1. And so I'll get -1. And I think I messed this up on the answer key, but I didn't do, went over 2, 1. It's actually 2, -1. So it'll be like right there. So as I go to the right, my graph is going down, right? So as x goes to the right, f of x is going down. And then as I go to the left, well, I can't keep going to the left. I have a boundary here, right? So I go up. So as x approaches -2, my f of x goes up to positive infinity. Okay, and then I look at this one. As x goes to the right, this one, g of x, not f of x again, goes to infinity. And as x approaches that asymptote, which is at 2, g of x goes down to -infinity. -infinity. Okay. So how I find that second point is I really want to match that base, whatever that base is. So I just say, what do I plug in for this that I can get the same number for? So for this problem, it'd be x equals 4, right? Well, that is just my h, which for this problem, what makes this 0? That'd be 0, right? My h would be 0. So it's just 0. It's 0 plus 4, right? Or my b plus h. B plus h. Let me make sure. B, let's see. Yeah, b plus h. Yeah, b plus h. So it's always going to be b plus h. Oops, not comma. B plus h, right? So my b would be 4. 4 minus 2 is 2. Yeah, that works. Okay. And then my k, and then my what I get out, well, if I take this and I just get the base, log of 4 would be 1. 1 times my a, and then I add my k. So this is just going to be a plus k. So I can always find those 2 points. Why did I put 4? Sorry. Probably confusing you. That should be h. So I can do this point, h plus 1 comma k, and b plus h comma a plus k. And I just label my points. So if I'm graphing this one, I graph those 2 points. So I identify my b, identify my h, which is 0, identify my k, which is what's being added to it after. Now notice this is not in parentheses. This +2 is not in parentheses, where this one is. +2 is in parentheses. So that means my k is going to be 2. And then my a is what's being multiplied by the log, so this a would be -1. And now I can go ahead and find out my 2 points. So h plus 1, so that'd be 0 plus 1 is 1. And then I get my k. My k is just 2. I just put k here. So I get this point 1, 2. So I get this point, move over 1, 2. I get this point 1, 2. And then I can graph my second point, which is h plus b, comma a plus k. So h is 4, 4 plus, or sorry, my h is 0, and my b is 4, so that'd be 4. And then I get out a plus k, so -1 plus 2 is 1, so 4, 1 over 4, 1. Now I graph my asymptote, which is always h equals whatever h equals, sorry. I'm trying to do this fast. So that'd be h equals 0. But my vertical asymptote is always y equals, or x equals h. So that'd be 0 for this problem. So there's our vertical asymptote, and now I can graph it. It's going down to the right and up as we approach that asymptote. All right, so these ones, I'm just rewriting this. 32 raised to the 7/5 is equal to 8x. And now 32 raised to the 7/5, it's a fifth, that means it's a fifth root. Fifth root of 32 is 2. Now I raise that to the 7th power, and that is 128. So that's 128. This one a little bit more work. Since both these logs are both log 11, I'm just going to take what I'm taking the log of and set it equal to each other. And since it's a quadratic, that means that I'm going to have to set this quadratic equal to 0. So I subtract 28x on both sides, and I get -23x. Now, since it's quadratic, I could use quadratic formula, or I could use CAB, and this is factorable, because what times what is -108 and adds to -23. There should be an x there. And that is -27 and -27 and 4. So x minus 27 times x plus 4 equals 0. So that means x equals 27 and x equals -4. So those are two solutions to the quadratic equation right there. But I got to make sure it's the answer to the logs, right? So I can't take the log of 0 or negative. So I notice when I plug in this -4 in for this x, I get a negative. I can't take the log base 11 of a negative, 112? Can't do that. So the only correct answer would be for the log is 27. Approximating value, so I want to rewrite this number in terms of either what I'm taking the log of or its base, right? So I can rewrite this as log base 3 of 15,309. I can divide that by 7, and it goes in evenly once. So that means I can divide it by 7. So that means I'm writing 2 logs and adding those 2 logs. And when I divide that by 7, I get, what is it? 2,187. 2,187. Okay, and now I try to divide that by 7 again, and it doesn't work out, right? So that's 2187. I'll write a little smaller, 2187. Okay, so that means I'm going to try to divide by my base 3. Well, it turns out that 3 raised to the 7th is 2187. So I can rewrite this as log base 3 of 7 plus log base 3 of 3 raised to 7. Now I can bring that 7 out front. And log base 3 of 3 is 1. And log base 3 of 7 is 1.7712. So that's 7 times 1. So I just get 8.7712. Okay, this next one, I'm going to solve this equation for pH. I'm just going to solve this equation that is already solved for pH for H+. So I need to rewrite this as an exponential, right? So 10 raised to pH is equal to 1 over H+. Well, since this is a fraction, I can just flip it and get H+ equals. I just need to flip this one, right? So 1 over pH, or 10 raised to pH, right? So now I can plug in any pH and just take 1 over 10 raised to that pH, and then I can have my answer, which is, if I round correctly, it is 0.0043. Okay, this next one's a little bit more work, quite a bit of work actually. because I can't change the bases to be the same, I'm going to take log of both sides. So log 14 raised to x minus 5 equals log of 8 raised to x. I can move the x minus 5 out front, and since it's two things, I want to put it in parentheses. Move this x in front. Okay, and now I can distribute the log 14, so I get x log 14 minus 5 log 14 equals x log 8. Now I want to move my x's to one side, and I want to move my logs, log 14, not 19, to the other side. So I'm going to move x log 8 and minus x log 14. Now I can factor out an x. And now I can divide by what's not x, right? So I can divide by that. And you can just leave it as this in log form is fine. So log 8 minus log 14, that's a minus sign there. So x equals minus 5 log 14 over log 8 minus log, oh geez, terrible writing. Should be 1/4 there, log 14. Okay, so you can leave it that. This one's a little bit easier. Do you take log of both sides? The x gets moved out front, and this one's a little bit easier just because you don't have two terms. You don't have two terms, you don't have two y's or two x's. So I just divide by log of 9 on both sides. Then I just do that in a calculator and type that in, and I get x is approximately 1.548. So that's the first part. And next part, same thing. This is kind of a harder problem because we have two y's. We have the inequality, so we just keep it the same. So we're going to move this out in front when we take the log of both sides. So I'll take the log of both sides and then move my exponents in front. So y minus 3 times the log of 6 is greater than y log of 11. And so now I'm going to distribute the log of 6 to both of these. So y log 6 minus 3 log 6 greater than y log 11. So I can move my logs to one side. So I get minus 3 log 6 greater than y log 11 minus y log 6. Factor out a y. Factor out a y. So this y is going to be gone, right? And then I'm going to divide by what's not y. Log 11 minus log 6. Log 6. So then we'll do it on both sides, right? So then at the end we'll get minus 3 log of 6 over 11, or log 11 minus log of 6. This one I can use change of base formula, so take the log of the top over the log of the base. Type that in my calculator. And I get approximately 3.2619. This I want to use change of base formula, but first I need to get the log by itself. So I'm going to divide by 12. If I had addition, I would add and then divide. So you want to just do things backwards, add and subtract first, then multiply or divide. But I want to get the log by itself, right? So here I want to divide by 12. So I get log x 8 equals 15 over 12. And now I want to get log of x by itself. So it wants me to solve for log of x. So I use change of base, and I take the log of the top over the log of the bottom. And now this is just, I can multiply both sides by log of x. So I get log of x. And then I can multiply both sides by 12. Right? And then I can divide both sides by 15. So we get 12 log of 8 over 15. And you can put it all over the whole thing if you wanted to. So there's in terms of log x equals. And now switching these ones, going from into ln form, because e base e, that means it's a natural log. So ln of e to the x equals 7. ln of 17 equals 2x. Vice versa, switching it back to exponential form. So that'd be e to the 8x equals 7. This would be e to the 17 equals 2x. And now getting down to, I'll do this two different ways, number 16. The easiest way to do this one is to rewrite 81 and 27. So same base, so I can write ln of 81 is 3 to the 4th minus 10 ln of 3 raised to the 3. So I can bring the 4 out front and the 3 out front there. So 4 times 8 is 32 ln of 3. And this would be minus 30 ln of 3. Now they're both ln's of 3, so now I can just subtract and I get 2 ln's of 3. Now your test might not be like that, or your quiz might not be like that, so just in case it's something different, we want to use the other rules of exponents or logarithms that say when we're adding, we multiply, and when we subtract, we divide. And if ever there's a negative ln or negative ln, that's going to be in the denominator, and any positive ln will always be on top. So these ones I could move the 8 on top, so like ln of 81 raised to the 8 minus ln of 27 raised to the 10th, and then since we're subtracting, the positive ln is going to go on top, and the negative ln is going to go on the bottom, and I'm just taking the ln of one thing. Now, and then I can type that in my calculator, and I get ln of 9, which is the same as ln of 3 squared, which is the same as 2 ln of 3. So all three of those would be correct answer. All right, onward. So now we have Cho who's saving. So we're going to use APERT because it's continuous in interest. So P is your principal initial rate, which is 228, or sorry, 2800. And then E raised to R, which is our rate, which is 0.3%. So I need to turn that to a decimal, so that's 0.003. And then T is time in years, and our years are 5 years. And then she wants to know, her friend says, well, why don't you wait till 10 years? So we're actually going to use 2 of them, and then we're going to see which ones that makes more in 10 years, how much more. So we're going to take P, which is 2800, E raised to R, which is 0.003, times 5, or times 10, because that's going to be larger. And then we're going to take 2800, E raised to 0.003, times 5, and then we'll subtract these to see how much more is in this one than this one, right? So eventually we'll be just subtracting these two numbers, and so those two numbers are, calculator it or plug them in, and we get 2800, 85.27, and 2442.32. So if we subtract them, subtract those two numbers, we get 42.96. So 42.96. So is it really worth it to wait 5 years for $43? I don't know. Okay, and then last couple of them. So 18, so we're solving ln. So whenever we solve ln, it's just like solving for a log, right? So we switch it to exponential form. Well, the base of ln is of something, it's just log base e of that something, right? So I'm solving this, I would be bringing my base e raised to the 6th is less than what I'm taking the log of, 2x plus 5. So then I want to solve for x, so I subtract 5 on both sides, so subtract 5, and then divide by 2. Remember, if you divide by negative, you got to flip that inequality symbol. So I just type that in my calculator. So x is greater than, right? The alligator's eating the x, so the alligator's eating the x. And so I take e to the 6th, subtract 5 from it, and then divide by 2, and I get approximately 199.214 if I round to the thousandths place. Okay, last problem. A little bit of work. There's going to be a couple just like this, but really we can use our calculator a little bit, but we're going to write an equation is y equals r. We used in the book a e raised to kt. Right, so that's the equation that we're going to use. Okay, and then we can solve for k by getting e by itself, right? So that's y over a equals e raised to kt. And then we can take the ln of both sides. So y over a equals ln of e, and ln of e just equals 1. So I can bring the kt in front. And now we can either solve for k by dividing by t, or we can solve for t by dividing by k. And this one asks for years, so it's asking for time in the second equation. So first we got to find our k, and then we'll find our t. Okay, so if in 1980 that'd be year 0, so our t would be 0, and our y would then be 410 851, and then in year 2017, which is 20, 30, 37 years later, our y is now 739,818. Okay, so I'm going to use those numbers in order to solve for k, right? So I know my t is going to be 37. Okay, I know my a, which stands for the initial amount, just like our principal did, so that is 410. So 410,851. I'm going to take that and I'm going to divide that by our ending amount, which is 739,818. And then I'm going to take the ln of that, and that's going to equal k times t. And if I want k, I'm going to divide by t. So my divide by t, difference in time here is 37. And that's going to be my k. I can round to the thousands place on that one. So if I round to the thousands place, I get k is equal to 0.0159. And now I can use that. Now I can solve for t on this separate equation. So if I write my equation, I now have my k. So it's y equals my a, which is 410,851, e raised to my k, which is 0 or 0.0159 t. So there's my equation, and I can plug in any t, or I could plug in a y, and I could solve for t, and that's what this last part asks us to do. When will it reach 1 million? So when will our ending, our y, reach 1 million? Well, I divide that by our a, which is 410,851. I take the ln of that, and then I divide that by my k, which I just found is 0.0159, and that's going to equal my t. My t is about approximately 55.9, so about t equals 56 years later. So if I add that to 1980, 56 would be 2036. And so there you go. There's how you do all these problems. Hopefully that helps.